Let's find the area of the shaded region here. As you notice, we have a square, and then it looks like we've cut out a circle, so the shaded area is around the circle. So we're going to take first the area of the square, and to do that, that would be area equals side squared. The length of the side here is 14 meters, so 14 meters squared gives me 196 square meters. Now let's find the area of the circle with a radius of 7 meters. So we know the area of a circle is found by pi r squared. Pi times the radius of 7 meters squared would be 49 times pi square meters. So now let's take the area of the square and subtract the area of the circle. So in your calculator, we would take 196 and subtract 49 pi, and the screen in your calculator would look like this, or similar to this. And then if I round this to the nearest hundredths place, we need 2 decimal places. Look to the right, and this digit is less than 5, so we want to keep that as 42.06. And the units, remember, were square meters. So the answer of the area of the shaded region would be 42.06 square meters. Here we have another example of finding the area of a shaded region. In this case, we have a larger circle with a radius of 18, and it looks like we've cut out a smaller circle with a radius of 14. So just like the previous problem, we would take the area of the larger figure, which is a circle, and subtract the area of the smaller circle, so that we're basically cutting out that part and leaving the shaded area. So the area of the larger circle, I'll note that with just a little sub L, is equal to pi r squared, which would be pi times 18 squared. That would give me 324 pi, and our units would now be square meters. Remember that these were meters, so I could do this, so that I actually get 324 square meters, 324 pi square meters for the larger circle. And then we're going to do the same thing for the area of the smaller circle, but the radius is 14, so pi times 14 squared. That would also be in units of square meters. 196 pi square meters. So take the area of the larger circle, subtract the area of the smaller circle. So the 324 pi minus 196 pi would give you 128 pi. And then let's round our answer to the nearest hundredths, which would be, if we type in our calculator 128 pi, I would get 402.123857597. So if I'm rounding to the hundredths place, the 3 would tell us that we don't need to round up. We'll stay right at 2. So my answer for the area of the shaded region would be 402.12 square meters. Here we have another example where I'm finding the shaded area. So I want the area of this square, but it's not as simple as some of our other square problems because we aren't sure at this point what the length of the side is. We are given that the square that it's enclosed in has sides of 10 inches in length. So if we play around with it a little bit, there are actually a couple of different approaches you can take. But if I know that this is a length of 10, and I know that this also, if I drew along a line there, would be a length of 10, what I've formed are 4 right triangles, and that would make these lengths all 5. half of 10 is 5. So then if I wanted to find the side of the square, you're actually looking at the hypotenuse of a right triangle. And so we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. We want to make sure that the c squared part is your hypotenuse. I'm going to label that with an x. So 5 squared plus 5 squared is x squared. So 25 plus 25 is x squared, which gives me that 50 is x squared. Now to find x, using the square root property, I would take the square root of both sides of the equation, which would leave me with the square root of 50 is equal to x, since the square root of x squared is x. We're only concerned with positive roots here since we're looking at distance. Now, if I was only looking for the length of the side, I could actually simplify this radical, and the square root of 50 is also equal to the square root of 25 times 2, which is then simplified to be 5 times the square root of 2. However, even if I didn't know that this was equivalent to the square root of 50, I could also use this form. When I find the area of the square, it would be side squared. We just found the side, so this I guess we could have called an S for side. We used an X, but that side we found was equal to the square root of 50. And if I square that, then I end up with just 50. So it would be 50 square inches. You would have gotten the same answer had you simplified the radical. It would have looked like 5 times the square root of 2 squared. 5 squared is 25, and the square root of 2 squared is 2, which would still leave you with this 50 square inches. Here we're going to find the shaded area again. And if you look at this picture, the approach we would take would be to take the area of the largest circle, and then we're cutting out these smaller circles. So we'd subtract the area of each of those smaller circles, and those are identical circles. There's a little bit of liberty taken with some of these drawings. So even though this doesn't say that this is the center, by this drawing we are to assume that the center of the circle would be here. Okay, so let's find the area first of all of the largest circle. It would have, since the diameter of the circle is 26, then the radius of the circle would be half of that, which is 13 centimeters. So pi times 13 centimeters would be 169 pi square centimeters. Now to find the area of the smaller circles, we'll need the radius of each of those circles. So we just found that this distance would be 13 centimeters since the radius of the circle is 13. So the radius of the smaller circle here would be half of that, which would be 6.5 centimeters. And then the same thing here. The radius of this circle would be, and you can draw that radius anywhere in the circle, but I guess here would be better to visualize. There's 6.5 centimeters. Okay, so the area of the smaller circle would come from the radius of 6.5 centimeters squared times pi, or pi r squared, which would give you 42.25 pi square centimeters for both of those circles. So now we would need to take the area of the largest minus those two smaller circles. So the 169 pi minus 42.25 pi minus another 42.25 pi would give you 84.5 pi, And then when you type that in your calculator, you would get 265.46. We're going to round this to the hundredths place. So we need 2 decimal places. My number 4 is less than 5, so I'm going to stick with 6 and not move up. So 265.46 square centimeters would be the area of the shaded region here.